Hello everyone, welcome back. Today I am going to start Unit 3 of Class 8, that is Minerals and Power Resources. Now, without any delay, let's begin. So, what do you mean by mineral? A mineral is a naturally occurring substance that has a definite chemical composition. For example, look at your pencil, the lead you use in it, that's also a mineral. So basically everything around us that comes from the nature and has a specific composition, that's a mineral. Now, minerals are formed naturally through various geological processes without any human interface. They can be identified by their physical properties like color, density, hardness, and also by their chemical properties like solubility. Alright, before we go to the types of minerals, let's understand what is rock. A rock is an aggregate of one or more minerals, but it does not have fixed composition of those minerals. The rocks from which minerals are mined are called as ores. Okay. Now, coming to the types of minerals, they are mainly divided into metallic and non-metallic. Among the metallic minerals, we have two categories, that is ferrous and non-ferrous. Ferrous means the ones which contains iron, and non-ferrous means the ones which do not contain iron. Metallic minerals contain metal in their raw form. These metals are good conductors of heat and electricity, and they usually have a shiny appearance. Examples of metallic ores are iron ore, bauxite, and manganese. And ferrous minerals like iron ore, manganese, and chromite contains iron. And non-ferrous minerals do not contain iron, but may contain other metals such as gold, silver, copper, or lead. No, non-metallic minerals do not contain metals at all. Examples include limestone, mica, and gypsum. Minerals like coal and petroleum are also classified as non-metallic minerals. Let's see how minerals are extracted. Minerals can be obtained by mining, drilling, and quarrying. The process of taking out minerals from rocks buried under the earth's surface is called mining. You have probably already heard this word, right? When minerals lie close to the surface, they can be taken out by removing the surface layer. This is called open cast mining. And now, when minerals are located deep underground, or deep holes are called shafts, are made to reach them, and this method is known as shaft mining. When minerals are extracted by digging deep wells, that's called as drillings. And when the minerals lie near the surface and are just dug out directly, that process is called as quarrying. Alright. Now let's move to the next topic, that is distribution of minerals. You see, minerals don't occur everywhere. They are found in different types of rocks depending on how those rocks are formed. So it mainly depends on the types of rock because that decides which kind of minerals we will get. Now let's understand something important. That is, metallic minerals are mostly found in igneous and metamorphic rocks. You might wonder why only in these rocks. Can't they also be in sedimentary rocks? So, igneous rocks are formed when hot molten magma cools down. During that cooling, minerals crystallize and get locked inside. That's how metallic minerals like iron, copper, and tin form. And metamorphic rocks are formed when existing rocks get heated and pressured deep inside the earth. That heat and pressure change their structure and form new minerals. So again, metals are formed here. But in sedimentary rocks are formed by layers of the sand, mud, and shells deposited over time. So they usually have non-metallic minerals like limestone or gypsum. So remember, igneous and metamorphic rocks are metallic minerals and sedimentary rocks contain non-metallic minerals, right? Now let's travel around the world and see where these minerals are found continent by continent. Now first is Asia. In Asia, China and India have big deposit of iron ore. And if you check the map, you will see iron is widely spread here, and countries like China, Malaysia, and Indonesia are leading producers of tin. So Asia is rich in both iron and tin. Now in Europe, it's one of the leading producers of iron ore. That's one of the reasons Europe became industrially developed very early, because they had both coal and iron, the basic ingredients for industries. Then comes North America. Here we have three important mineral zones. The first one is Canadian region, that is in north of the Great Lakes, and second one is Appalachian region, and third one is Western Mountain region. These areas have iron, coal, copper, and almost everything you can name. Now in the South America, Brazil is very famous because it's the largest producer of high-grade iron ore in the world. And Chile and Peru both are known for copper. So if you remember just this, Brazil is iron and Chile and Peru is for copper. That's more than enough. And moving to Africa, this continent is just full of mineral wealth. It's the world's largest producer of the diamond, gold, and platinum. That's why many countries here depend on a lot on mining. But also many have faced challenges because of over-dependence on raw minerals export. Then we have Australia, that is very rich too. It's the largest producer of the bauxite and also produces gold and diamond. The places like Kalgoorlie and Coolgardie in the Western Australia are famous for gold. You don't have to memorize all these names. Just have an idea which continent is rich in which mineral, and that's enough for smart preparation. And finally, even the Antarctica has mineral deposits. The coal is found in the transatlantic mountains and iron near the Prince Charles Mountains, but mining is not allowed there because of environmental protection laws. Now, how do we use these minerals? The copper used in wires, pipes, and coins, and silicon used in computers and chips and taken from quartz, and aluminium made from bauxite ore used in airplanes and packaging. So, minerals are literally the backbone of industrial development. No, but remember, minerals are non-renewable. That means once they are gone, they are gone. They don't come back soon. So we should use them carefully and recycle, reuse, and avoid waste. That's what we call conservation of minerals. Now let's talk about power resources. Basically the source of energy we use to make our life run. For example, solar energy, hydropower, wind energy, fossil fuels all come under power resources. These are divided into conventional and non-conventional source. The first one is conventional source. These are the ones we have been using for a long time, like firewood and fossil fuels. The first one is fossil fuel, mainly used for cooking and heating in rural areas. And second one is fossil fuel, formed from plants and animals, buried millions of years ago under heat and pressure. From that process, we get coal, petroleum, and natural gas. The coal is the most common fossil fuel. We use it for domestic purpose and in industries like iron and steel. Electricity from coal is called thermal power. And you know what? Coal is also called buried sunshine because it formed from ancient plants that once captured sunlight. Petroleum is that thick, black liquid found between layers of the rock. It's drilled from both offshore and onshore areas. It's called black gold because it's so valuable like gold. Countries like Iran, Iraq, Saudi Arabia, and Qatar are leading producers. The natural gas is often found with petroleum. It's released when crude oil is brought up. In India, we found it in Jaisalmer and Krishna Godavari Delta, Tripura, and offshore Mumbai. Now comes hydropower, that is energy from water. Rainwater or river water is stored in the dams. When it falls from a height, it moves the turbine blades which rotate and generate electricity. That's how we get hydroelectric power. Around 1/4 of the world electricity comes from this. Countries like Norway, Brazil, and China are top producers. And in India, Bakranangal, Gandhi Sagar, Nagarjuna Sagar, Damodar Valley are major projects. If you look at your textbook image, you will see how water flows down and turns the turbine and generate power. That's the whole process. Now let's see the modern and renewable source of energy, the ones that never get exhausted. The first one is solar energy. The sunlight is collected by solar cells, joined into panels, used for heating, lighting, and generating power. Second one is wind energy. The windmills use high-speed wind to turn turbines and produce electricity. It's clean, renewable, and eco-friendly. The third one is nuclear energy. This comes from radioactive elements like uranium and thorium, and when these undergoes nuclear fission, they release huge energy. And next one is geothermal energy. The energy comes from the heat inside the earth. In some places, hot springs come to the surface, and that heat can be used for cooking or generating power. In India, you will find geothermal energy in Manikaram, it is in Himachal Pradesh, and Buga Valley in Ladakh. Now, let's move to the next topic, that is tidal energy. So, what is tidal energy? It's the energy that we get from the rise and fall of the ocean tides. Okay, you all know that sea level keeps going up and down. That's because of gravitational pull of moon and sun. When the water level rises, we call it a high tide, and when it falls, there's a low tide. And now you might wonder, how do we get electricity from that? Let's understand this in a simple way. Imagine there is a dam built across a narrow bay or an estuary. Somewhere the sea water can easily flow in and out, like this. When high tide comes, the sea water flows into the dam area. That flowing water has a lot of energy. It's powerful. So we use that kinetic energy of moving water to turn the turbines that are fitted inside the dam. When the tide goes down during low tide, the water that was stored inside the dam starts flowing back to the sea, again turning the turbines. So basically both high tide and low tide movements are used to rotate the turbines, and that rotation helps generate electricity. This is what we call tidal power. That is clean, renewable, and endless, because tides will always come and go, right? So it's a great non-conventional source of energy. Now let's move to the next one, that is biogas. So this one is very simple and very useful, especially in rural areas. Biogas is made from organic waste, things like dead plants, animal dung, and even kitchen waste. All this waste is put into a big tank. It's called biogas plant. Inside the tank, there is a bacteria. These are called anaerobic bacteria, means they can live without air. These bacteria slowly decompose the waste material and produce a gas. That gas is called biogas. Biogas mainly contains methane and carbon dioxide. Methane is the one that burns. That's why it's used as a fuel for cooking and lighting. It's eco-friendly, cheap and perfect for villages where animal waste is easily available. So it's a small idea but a big solution, that is clean energy from waste. And that's it for today's class. I will upload Unit 4 in coming days. Till then, like, share and subscribe.